Good afternoon. My name is Tyler, and I'm the team lead for the cargo plane senior design project. So just a brief summary. I'm going to be going over just our team breakdown, our projected schedule, some background of the project, our budget, some background of each of our subcomponents, and then major sources. So the team breakdown, our project is broken down into the subcomponents of our plane. So I'm the team lead. We have sub-team leads for the wings, tail, fuselage, and landing gear and motor control components. Our advisor is Professor LaRue, and over the course of the project, each of us are taking 4 units total, so it's broken up through the entire year. So this quarter, each of us is taking 1 unit without special circumstances. So the timeline, this fall quarter, we're pretty pressed for time, or this year in general. Our competition is at the end of spring, or beginning of spring, end of winter. So this fall quarter, we finished our design in the first 3 weeks. We began training for manufacturing and monocoating. We did some laser cutting training, all in preparation to build the plane. So those have been done. We've also done motor testing and just started general fabrication. We still have monocoat training, which is actually tomorrow. In the winter, that's when we are finishing our manufacturing, begin assembly, start doing testing, because we'll have our competition soon after that. And our report for our competition is due about the end of winter. In the spring, that's when we do our final assembly, final testing, and compete. So our competition, this senior design project is built to compete in the SAE Aero competition. They have East and West. Of course, being on the West Coast, it's easier to be entered into the West. So we have registered. We are competing. Our competition is in Van Nuys at the beginning of April. There are 75 teams in this competition, split amongst 3 categories. We have regular, micro, and advanced. Our team is designing for the regular competition. It's a conventional plane. Micro has some smaller components. Advanced also gets pretty expensive with motor components. So we're in the regular class. Some of the requirements for the project, we need a 2D drawing, we need to write a report, we actually have a presentation, and we have to compile a technical data sheet of our plane itself. So our goal, the goal of this project in general, of course, is to compete in the competition. So we're on track to do that. We are hoping to place, and comparing our previous designs, as you can see here, the top 2 are from 2 years ago, and this bottom 2 pictures are from last year. Our plane from last year was pretty competitive with those who did compete, so we're hoping to take that plane, make improvements, and when we enter this year, place. So for our budget, it's a pretty expensive project, mainly just because of registration fees. The registration itself is $1,000, amounting to about a quarter of our budget itself. Wood is the next expensive thing. We utilize balsa wood and poplar, and for the cuts that we need and the amount that we use, it's pretty expensive. So the wings and the tail are wings, tail, and fuselage are the main users of wood. So you can see they amount to about $2,000 of wood amongst themselves. Our next biggest cost is the motor, and then I covered the team costs as well. So we're expecting about $4,500 in expenses. Our material fees we're getting about $1,900 per quarter because of how large our team is. That being said, most of our costs are in the fall and the winter, so we're pretty much only getting about $3,800 by the time that we need it. So we're supplementing that with Europe funding. Last year we got about $700. This year we're hoping for a bit more. We have a couple more expenses, so we'll see how that goes. So going into the plane breakdown, we're going to start looking at our wing. So our wing, the competition itself, we're flying at low speeds. So we look at high lift airfoils at low speeds. We're flying about a 500,000 Reynolds number. So the Epler 423 is the best airfoil that's feasible in manufacturing. 2 years ago we used a sailing airfoil, and it had a very sharp trailing edge, and it was very prone to breaking. So we moved to the Epler. We're looking at a high wing, rectangular planform wing. We've got 12 feet wingspan, and that's according to the competition. That's one of the constraints. And we've got a chord of about 2 feet, and our stall speed is 24 miles per hour. We have a 20% factor of safety for takeoff for about 29 miles per hour, and a 30% factor of safety for landing at about 30 miles per hour. So for our tail, we're going with a conventional setup. We have a NACA 12 airfoil. As you can see, with both the wing and the tail, we have cutouts to reduce weight. One of our main goals for our project is weight reduction, just so that we can focus on the cargo itself, that's the cargo plane. So we have truss design, so reduce weight, and we've got a 5-foot horizontal stabilizer and about 1.5 feet vertical stabilizer. So for the fuselage, we're going with an octagon design. It's more streamlined than the regular rectangular box. It's a little bit harder to manufacture. As you can see with our wing integration, we're going to have to kind of streamline that connection because we do have a rectangular box where the wings are connected, just for the spar support. It's a pretty long fuselage. It's about 7.5 feet. That's to hold the tennis balls that are pictured in the top or the middle plane, and we have the cargo accompanying the tennis balls, which are metal plates down at the bottom. So those are our two cargos. We have tennis balls that are acting as passengers and metal plates that are acting as their luggage. So we're expecting to hold 56 tennis balls for about 7 pounds, and their luggage will be 28 pounds. And the fuselage is made of poplar and plywood. So for our controls, we have a controller, an ESC unit, a power limiter as constrained by the competition. We have a 22-volt 6-cell battery, and we use servos for our control surfaces. We have control surfaces on the wings, the tail. We have a nose gear that also uses a servo, and our motor is also controlled by this controller, of course. So that's pretty much the plane breakdown and just our project. Do you have any questions?